Hello, pre-calculus folks. This is Mr. McAllen, and this is going to be a quick lesson on how to plot a fully developed sine function. So what we're going to be working with is this type of function, sine function. And the first thing we want to do is when you look at the function, you want to first write down what the a, b, c, and d values are. So looking at this function, the a value is 2, the b value is 3, the c value is negative pi, and the d value is negative 1. Second thing you want to do is you want to graph the midline, and that is going to be the equation y equals whatever the d value was. So we're going to plot y equals negative 1. So I'm going to draw a line for my midline because this is the spine of the sine function. It's the middle of the function. In fact, this will be the line that I draw all my x-axis tick marks on because it will be perfectly centered between the highest and lowest point. The next part is to graph the amplitude, the up and down amount, and the amplitude is 2. So I'm going to graph just a construction grade line, very light, 2 units above and 2 units below, and that's just to help me notice where the sine function is trapped between. So that's basically going to be at y equals 1, going up 2 from the midline, and I'll write y equals negative 3. And I'm going to write on the blue line, just so that we know that this is the midline. Midline means the middle of the function. Next thing we're going to do is find the starting point, and we gave a nice easy equation for how to find the starting point. It's the negative of the c value divided by the b value. This is found by taking the internal part of the function. The starting point is found by setting 3x minus pi equal to 0, and then when we solve it, we get 3x equals pi, x equals pi over 3. So now I know my starting point is going to be, my x starting point is going to be at pi over 3. Now I want to find my ending point. The function starts at a value. I'm going to call that pi over 3, and it ends at a value. So I'm going to call that the ending point, but I got to figure out what its value is. So the ending point is always equal to what the starting point was plus the period. Now the period is the full amount of, if this were a time-based function, the amount of time to go through a full cycle. And the way we find that period is we calculate period is equal to 2 pi over our b value. Since our b value was equal to 3, my period is equal to 2 pi over 3. So this is pretty nice because to find my ending point, I need to add my starting point to the period, which is going to be, starting point was pi over 3. I'm adding to it 2 pi over 3. So my end point will be equal to 3 pi over 3. Now, which is equal to pi, but I'm just going to write 3 pi over 3. If you want to write as pi, that's fine. The next part of the process is to subdivide the x-axis, well, or the midline 3 times, because we need to get 4 even intervals. So in red pen, I'm going to subdivide my interval once. I'm going to subdivide this interval once, and I'm going to subdivide this interval once. So I get 4 even intervals. I don't even care right now about marking the interval tick marks. I just want to make sure I have 4 even intervals or 5 tick marks total. The last part is to draw the function for the sine or cosine. Now, the sine function has a variation pattern, and this is kind of like a code. It goes from 0 to 1 to 0 to negative 1 to 0 throughout its quadrantal values. But with all this transformation that we did, this really just tells us the sine value goes from a minimum, from its middle value to its highest value, to its middle value, to its lowest, to its mid again. And what we do is we start out at the starting point. I'm going to draw this in green. And we start on the midline because a 0 means middle value. I'm going to start there at the middle value. When I move to my next tick mark, I'm going to be at my highest. My next tick mark, I'm going to be at my middle. My next tick mark, I'm going to be at my lowest. The last tick mark, I'm going to be at my middle again. So when I draw the sine function, I have that function from start to finish. Remember, the period was equal to 2 pi over 3, and that's the duration of the function from start to finish. And the amplitude was equal to 2. That shows how much it extends from the midline. The midline value was y equals -1. And the phase angle C equals pi. That helped move our function left or right by a certain amount. Hopefully this video helps you in terms of plotting one cycle of the sine function. And the next video in the series will talk about how do we do it with a cosine function.